All right, so what is our mnemonic device used to remember our trig functions? SOHCAHTOA. So, SOHCAHTOA, which is saying sine is opposite leg over the hypotenuse. Really, it's the leg, not just a side. Cosine is adjacent over hypotenuse, adjacent leg. And tangent, opposite leg over the adjacent leg. So that's one of the things we needed to talk about. Now, what are the other three trig functions that we mentioned yesterday? Secant. Secant gets paired up with cosine. What else? Cosecant and cotangent. Now, how do we get cosecant? It's a reciprocal of sine. Hypotenuse over the opposite. Secant is the reciprocal of cosine. Hypotenuse over adjacent. And cotangent is reciprocal of tangent. So they all match up. Sine goes with cosecant, cosine goes with secant, tangent goes with cotangent. The only pair that really makes sense is tangent and cotangent. Sine, or S and S do not go together. It's not sine with secant. So we got to be careful about that. If we can find those six things, you can find everything else we need to do for these. So let's find those six trig functions for this right triangle. So we have my two acute angles here. Oh, those two colors are too similar. So what do we know about angles C and A? Supplementary? Complementary. They add up to 90 because they have to. So we'll get into more of that in a second. So let's look at sine of C. So sine of C, what two sides do we use for sine? Opposite over hypotenuse. So opposite is the side directly opposite of it, 27. And our hypotenuse is 45. Is that my final answer? No, why not? I got to simplify it. What can I divide both of those by? 9. So I get 3 over 5. Now, cosine. We're using this angle. Cosine uses what sides? Adjacent and hypotenuse again. Now, it's adjacent leg. Because technically, what is adjacent a fancy word for? Next to. So we have two sides next to it. We have 45 and 36. But 45 is not our leg, it's our hypotenuse. So our adjacent leg is 36 over hypotenuse. And of course, we simplify that 4 over 5. Tangent, C, is our opposite over adjacent. Our opposite side again is 27, adjacent is 56. Simplified by 9, we get 3 over 4. So those are my three regular trig functions, however you want to say it. Now, how do I find cosecant of C if I have sine? Just flip it. It's reciprocal. So cosecant of C is 5 over 3. And we want to see the simplified. 45 over 27, yes, but let's simplify. Secant of C is reciprocal of cosine, so it's 5 over 4. And cotangent of C is 4 over 3. And I want my sides in fractions, not decimals, not right now, not mixed numbers, but simplified fractions. Any questions about those six? Now we have to do the same thing for angle A. Sine of A. What happens to the opposite and the adjacent sides when we switch to the other angle? They change how? They switch. Now opposite is adjacent and adjacent is opposite, which is why we get the patterns that we do. But sine of A, now what's the opposite side of A? 36. Hypotenuse, still the same thing. That doesn't change. So we got 36 over 45, and we reduce it to 4 over 5. Cosine of A. What's our adjacent leg? 27, and our hypotenuse still 45. Simplify it, 3 over 5. And tangent of A. Opposite leg is the 36, adjacent 27, simplify 4 over 3. Again, improper fractions are fine. We want these ratios. Leo. I just started with C because C is on the left side. Doesn't matter. Okay, now, cosecant of A is what? Well, the reciprocal of sine. So 5 over 4. Yes, it's opposite, or hypotenuse over opposite, but I don't even want us to think about it that way. Think about it. We've already found the other stuff. Let's not find it again. So secant is the reciprocal of cosine. 5 over 3. Cotangent is reciprocal of tangent. So 3 over 4. So we have all 6 trig functions of both. We have 12 problems here that we just did. Now, I want to look at the patterns. What is the same as 3 over 5? Cosine of A. What is the same as 4 over 5? So we have these crisscross applesauce, yes, relationships. What else is the same? Cosecant of C and secant of A. These two are also the same. And if we want to really get into it, we have cotangent of C is tangent of A, and tangent of C is the cotangent of A. So really, there are 12 numbers up there, 12 ratios, but there's only 6 different ones. And how many different numbers are there if we just look at each part individually? 3, 3, 4, 5. And that's what? A triple. So when we reduce down our trig functions, we're going to get a triple.